Welcome, everyone. Welcome to the US-RSE 2023 conference tutorials. Today is October 4th, 2023, and we're very happy to have Lee Liming and Stephen Turoscy here to give their tutorial on using Globus platform services in research software applications. First, I'd like to remind everybody that we have a code of conduct, and we ask that everyone follow it. And I'm going to paste the code of conduct in the chat here. Also, if you're not a member of the US-RSE and would like to become a member, you can join the US-RSE at the webpage, and I'll drop a link in the chat as well. Now, this is a hands-on tutorial, and it's a follow-along tutorial, and I'll be acting as moderator, and either Lee or Steve will be in the chat to help you if you get stuck. But just remember, there's going to be a lot of folks on here, and we can't help absolutely everybody. So help is offered at a best effort basis, meaning that we won't be able to spend a lot of time with a single person or stop the tutorial. The tutorial is being recorded, so you can watch us on half speed, and there's also going to be slides posted as well, so you can follow along at your own pace once it's released. And with that, I'd like to hand it off to Lee and Stephen from Globus, and looking forward to a wonderful tutorial.
Thank you, Tim. My name is Lee Liming. My colleague Steve Turoscy and I are from the University of Chicago's Globus team. As Tim said, this is an interactive tutorial. And so on the screen right now, there is a QR code. If you scan that with your phone, or go to the URL that's in orange, bit.ly/RSE Globus, it'll take you to a Google folder that the conference has set up for us that has a couple of materials in it. One of them is a sign-up sheet for our virtual machine containers that will allow you to follow along in our Jupyter notebooks. The other is a information sheet that has the training materials and a cheat sheet in it. That'll just help you get started as we get into the interactive part. I'm going to be talking and giving a brief overview of Globus for the first 20 minutes or so, and then we're going to start looking at each of the Globus APIs. And when we do that, we'll use the Jupyter notebooks to show you how the code works. And that'll be the remainder of the tutorial. In addition to being prepared for the online exercises and the interactive exercises, you should also be prepared for our nationwide emergency alert test that FEMA and the FCC are conducting today. This will happen during our tutorial. So around somewhere between 2 and 2:30 p.m. Eastern time. I don't know what time zone you're in, so you'll have to do the conversion yourself. All of our phones are going to start blaring, and maybe other devices too. So just be aware that that's going to be happening. It would be best if you're on mute when that happens. So if you're not speaking or asking a question, please be on mute. I will do the best I can, and Steve will do the best he can. I think it'll probably be Steve who's talking then. And we'll just have to deal with that when it happens. I also wanted to make sure all of you who are coming to Chicago for the US-RSE conference in a week and a half are aware that I will be there. My colleague Greg Naraki from Globus will also be there. And you can visit us in person while you're there in the sponsor area at the conference. And so if you have questions from this tutorial, or if there's just anything you want to ask us about regarding Globus, we'll be there in person, and it'll be a great time to see us there. So I hope that you take us up on that, and I hope that you're coming to Chicago for the conference. It's going to be a great one. Before I go any further, I want to give you on one slide what is Globus. In a nutshell, we are a nonprofit service that is developed and operated by the University of Chicago on behalf of the global research and academic community. So everything that I'm talking to you about today and everything that Steve is telling you about is something that is run by the University of Chicago on behalf of all of you. assuming that you're in the research and academic community, which I presume you are. And so these are services that are supported by our subscribing members, which are generally universities and research laboratories. We don't take financial support from individual research teams, but instead by the institutions where you work. And so in most of your cases, you'll find that the institution where you work is already supported through a subscription. And so everything that we tell you about will be available through your campus. What we do is, or what we are trying to do, is to increase the efficiency and effectiveness of researchers engaged in data-driven science and scholarship through sustainable software. So we write the software, we provide it as services, software as a service, and a platform as a service, just like other cloud services like Amazon Web Services or Google Cloud Services or Microsoft Azure. And it's available for you to use. Globus is both platform as a service and software as a service. We've been operating it since 2010, so about 13 years now. All the numbers that you see on the screen right now were from a 12-month period that ended in the end of June of 2023. That's this year. So it's 1 year's worth of activity. Basically, what everything you see here all adds up to is that there are a lot of systems that are already connected to Globus at thousands of universities around the world, including hopefully ones that you work for or interact with in your work in research. Lots and lots of people have already been using Globus and have registered their identities with us. And lots of institutional systems, storage systems and compute have been connected to the Globus ecosystem. So you can use them through the Globus software as a service and platform as a service, which is the topic of the tutorial. So getting a little bit more specific, over these 13 years, we've been reimagining how research can be done, particularly research IT or information technology, by adding a suite of services to our portfolio. We started out with managed transfer and sync, that's data transfer and sync, from one institution storage to another institution storage, or between systems on a campus, or between personal systems that you may have at home or in your offices, and research institutional research systems. In addition to that, we also provide publication and discovery of data. We have been facilitating data sharing among researchers, and I'll show you examples of how that works in a minute. We are now providing managed remote execution, function as a service, as one of the APIs that we'll be talking about in this session. All this adds up to a unified data access system, which means that if you are doing research and you're using systems that are at your campus, that are personal, and that are provided by national facilities, Globus is a great way to interact with those, because we provide the same interface regardless of where the data is located or where the computing is happening. And recently, in the last few years, we've added reliable automation to this suite. So not only connecting things in the research world to the Globus ecosystem and providing uniform APIs to them, but also automating interactions with them. So things that have to happen over and over and over again. It might only be 3 or 4 steps, or it might be 100 steps, but doesn't really matter. You can define a flow in the Globus system and execute that through a single API call over and over and over again. All of this is provided to you as a platform as a service. That means we use RESTful web APIs and a software development kit in Python that you can download and use in your applications. We also provide it as software as a service, which means that all you have to do is have a web browser and go to app.globus.org and use all of the things that I just mentioned through your web browser. So when you put all that together, there are a few common features that make it useful for research software. First of all, we make it easier to use the institutional resources that researchers already have access to. That can be campus or laboratory or national storage, compute, and instruments. And in most cases, campus or institutional administrators have already installed Globus on shared resources. So if you have a shared compute system on your campus or shared data storage on your campus for research computing, there's a very good chance that your administrator, excuse me, has already installed Globus on that system, and you can use it without doing any software installation just by using either our web application or our APIs and the services that we offer. Another feature that's common across all of these APIs and all of these interfaces is that they use accounts that researchers already have. So rather than creating a new account to use with Globus or creating a new account to use with your application, researchers can use the campus or institutional credentials that they already have, and when they need to log in, Globus will take them to the campus login or the research lab login or whatever login is needed, and they can use an account that they already have using the research federations that exist already. If you don't have an account at a university that participates in InCommon or EduGain, or if you're at a corporation or someplace like that, there are fallback systems you can use, such as ORCID, which is it's not a Globus service, it's a research and academic service, but it works with Globus. We also use Google accounts, and there are a few others that I'll get to in a little bit. And then finally, all of this is made available using platform interfaces that are operated by our team at the University of Chicago. All of our stuff is hosted in Amazon Web Services. We use multiple availability zones for a lot of our APIs and hosted services so that it's available even in the event of single area outages. And it's all available through our Python command line interface and software development kit, which you can install with the familiar PyPy system that everybody uses with pip install, etc. And if you are not using Python, everything is provided via REST APIs, again, that are hosted in AWS, and you can access through any programming language that you use to access REST APIs on the web. So really quickly, running through some of these, we provide fast, reliable file transfer from any system to any system that has the Globus Connect software installed on it. I'll talk about that in a minute. It is very useful because it's fire and forget. Once you say, I want a transfer done, Globus takes over from there and manages the transfer. So even if you're transferring a petabyte of data from one university to another, and it's going to take a day and a half for that transfer to complete, or maybe even weeks, Globus will keep an eye on things, keep talking to both of the systems at either end of that transfer, and make sure that everything happens accurately and completely with checksumming and encryption and all of that stuff happening. Data always goes from one system to another. It never goes through our systems. So although we might see file names and directory names so that we can make sure that everything is happening correctly, we don't actually see the contents of any files. That all happens between the two systems that you've asked to perform the transfer between. And we also provide HTTPS access to data. So if you need to access the data directly from a Globus connected system, you can do that in your web browser and just upload and download files that way. I mentioned a petabyte data transfer, and when you're transferring that much data, it's important that you're doing it as fast as possible. So I threw up a little bit of performance information here about transfers that have happened recently between NCAR in Boulder, Colorado, and Argonne National Lab in Illinois, where there's about a 23 millisecond speed of light round trip time. So there's actually a significant delay. You can see that we were getting between 50 and 60 gigabits per second of data transfer between those two systems. Now, these are fairly significant research shared national scale research systems that have system administrators who do a very good job of providing the storage on their facilities and also administering their Globus Connect servers for the research community. And so they've tuned things to work very nicely. But even if you don't do that, Globus does a very good job of getting very good performance, even through firewalls when you're using personal systems. And in general, when you're using Globus, you can just request a transfer and not worry about it. It'll complete. When it completes, you'll get a notification that it's done, and you can be assured that you'll get pretty good performance, even if you're transferring something to another continent. In addition to data transfer, we also provide sharing. Sharing in Globus happens in place. So it's not like Google Cloud or Box or Dropbox, where you have to move your data into their servers in order to share it. With Globus, you can share data where it actually is. As long as Globus Connect is installed on a system, you can share directly from that system using our APIs in our web application. We provide fine-grained access control, so that means that you can set permissions at the directory level, and even within, you might have a whole bunch of data on a system. Individual directories can have different permissions on them, and you can use identities that your researchers have at any campus or research laboratory that participates in the Globus ecosystem, which is thousands. Let's see. Right. So we also provide discovery services, that is search, providing a scalable metadata store. This is backed in Amazon's Elasticsearch system. With what we add to that are the ability to set permissions on search indices and to set visibility controls on entries within an index based on research identities again. So your identity from whatever campus or research laboratory you belong to, you don't have to create a new account in order to use our search system. You can use the account that you already have. We do not enforce schemas in our search service. It's up to you to decide what metadata schema you're going to be using, what fields and values and what controlled vocabularies you use for all those fields, etc. But we provide the system that allows you to do index search over that information, over that data. And we also provide a query API that allows you to easily use facets in your search system. I'll show you examples of that in a little bit. But basically what that means is it allows people to browse the contents of the index very easily just by clicking on common values that are there and filtering down to just this the information that that's relevant to what they need. Very recently, we've added a new system, a new service called Globus Compute, that allows you to provide functions as a service. So if you have your laptop that you want to run things on remotely, or you have a campus compute system that is bigger and is maybe as a cluster, and you want to enable your applications to run functions on that cluster rather than on your web server. Or if you even have access to a national facility like one of the Department of Energy's leadership class facilities or NSF's high performance computing systems. You can install the Globus compute agent on that system and run functions on it remotely from your applications using Python calls. So it's a very convenient way in order to take advantage of compute systems that you may have for things that are more that need more computing power than you have available on wherever your application is running. And then one of the common use cases that people have as software developers is to create data repositories. We actually have a data portal framework that you can, that's based on the Django framework. And it knows how to use all of the services that I just went through. Globus for data transfer, for data discovery, and the Globus compute system for running analysis. So you can build a web portal very easily that uses all those systems and just uses API calls in order to access those services. Yep, okay. Oh yes, and there's one more thing. We also provide reliable automation. So all the things that I just mentioned, accessing storage, accessing compute, transferring files, running functions as a service, all of that can be automated using Globus's flow service. You, in Globus, specify what the steps are of your flow, and then Globus provides that flow for you as a service that you can then call and run it over and over and over again. And Globus makes sure that every step of the flow is executed reliably. If anything goes wrong, it either handles that failure and restarts automatically, or it lets you know exactly where something went wrong so that you can resolve it yourself. I'm going to skip over that. So you may be asking, how do I connect something like a compute system or a storage system to Globus? And I want to remind you that in most cases, if you're using a shared system like a campus system or a national system, this has already been done for you. We have a piece of software called Globus Connect Server, and we have another piece of software called Globus Connect Personal. Those are the two connectors for storage systems. So if we're talking about adding storage to the Globus ecosystem or making it available via Globus, you'd be talking about Globus Connect. The server version is for multi-user systems. It's usually installed by the system administrator of the system. It requires that the system be a Linux system, which is pretty common for multi-user storage systems in research and academia. But if it's your own system, then you can install Globus Connect Personal. It's a simple download, runs on Linux, Mac, or Windows, and it allows you to access the system where you install Globus Connect Personal using the Globus APIs and transfer data using our transfer service for reliable transfers. If you're talking about compute, we have a piece of software called the Globus Compute Agent. It is intended for use by individuals right now. We do not have a multi-user version of it. And so you would install the Globus Compute Agent wherever it is that you want your functions to be executed. And then you can use the Compute API to actually remotely invoke those functions on that system. So this is how storage and compute get added to the Globus ecosystem. Again, if we're talking about storage, there's an awful lot of storage that's being used by researchers. It's been very popular lately for universities to provide institution-wide contracts for cloud storage with Google Cloud or Amazon S3, Microsoft Azure and OneDrive and other things, Google Drive, etc. box. But there are also a variety of storage systems that are being used on campus for mass storage, for multi-user shared research storage. We provide storage connectors for our Globus Connect server software that work with many of those. And so all of the ones that you see here on the screen are options that you can use as, or that your campus administrators can use. And the nice thing about this is that because this is all accessed through Globus Connect server and our transfer API, it's the same interface, regardless of what crazy kind of software your administrators have decided to use. You don't have to worry about that. You just use the Globus APIs. It all looks the same to you. So really quickly, I want to summarize this from the perspective of a software developer, because that's what we all are in the RSE organization. If you're developing software, how does this look to you? So I've already told you about the fact that we have hosted on Amazon Web Services a bunch of APIs. These are all RESTful web APIs. And the whole rest of this tutorial is going to be going through each one of these in a little bit more detail, showing you what it does, what's great about it, and how you can use it in your code. And so you know that these are available as RESTful services on the web. We also have a web application that you can go to, app.globus.org, that basically provides you the user interface for all of these things. And so that you can use without installing anything on your system. You don't have to install a software development kit. You don't have to install a command line interface or anything. You just access it through the web browser. And so this is how many researchers transfer files from one institution to another. Say a researcher is moving from one university to another, they can transfer their whole archive of all the stuff they had at their first university to the other one just by logging into our web app and pointing and clicking and requesting a transfer, and magically it happens. But that's not what we're going to be doing as software engineers. We have a command line interface that uses our Python SDK. So we have the Globus Python SDK, and on top of it, there's a command line interface. This is all installable via PyPy. So you can use the command line interface in shell scripts or whatever scripting system you want to use. You can also develop applications using the Python SDK. And so you would, in your require statement, you could say, this requires the Globus SDK, and then you can call all of the API calls. You'll be seeing examples of this in our Jupyter notebooks in just a few minutes. And then if you want to build something like a data portal that's used by lots of researchers, we have, as I mentioned before, a portal framework that you can use to get started really quickly. It's a Django application that you can then extend to do all the things that you need to do. What you really don't need to worry about so much as a developer is where is all the data, because the data is going to be on storage systems that have been provided for you by your administrators, or that you have connected to Globus yourself by installing Globus Connect Server, or Globus Connect Personal. You would access that, though, or your software will access that by talking to our transfer service using the transfer API. And that can be done either in the web app, in the command line interface, or directly through the SDK, the Python SDK. As a detail that I'm not going to go into a lot right now, every Globus Connect connected system also provides HTTPS access. And so you can also access that data through normal HTTPS URLs, excuse me, but it's important to know that these are secure file access requests. And so very often they will require credentials in order to access them. So it's not like, sorry about that. It's not like everything is public and freely available. You may have to authenticate in order to follow a web link to get data from Globus Connect. Sorry about that. I thought it would be a good idea if I took a drink. And then again, if you are using our function as a service, you can use the compute API, and it will, on your behalf, make sure that all of your functions get executed on whichever compute system you've installed the Globus compute agent on. So when you request a function invocation, you say, I want to run this function, and here is the agent that I want it to run on. And the compute API will make sure that that happens for you and that the answer comes back to your application reliably. So really quickly, the APIs that we offer in Globus, there are 6 of them. We provide the Globus Auth API, which is research-oriented authentication and identities. So it's a login service, essentially, that allows you to export the login function from your application to Globus, and enables people who are using your application to log in using identities they already have at research institutions. The Globus groups is for groups and membership. So you can, through the API, create groups, configure groups and their policies, add and remove members from groups, and check the membership of a group to find out if a particular person is a member of that group. And then you can use that for authorization decisions in your application, should you choose to. The Globus Transfer API allows you to request transfers to and from Globus connected systems, storage systems, and also to do things like directory listings and basically that get you to the individual directories and files on the system. And then, set access control permissions and stuff like that through the transfer API. The search API is what I was telling you about earlier, index, search, and discovery. So with the search API, you can create search indices for your applications. You can set the permissions on those indices. You can add entries to the indices, and you can query the contents of an index to find all the entries that match particular search criteria. The Globus Flows API is what we use for automation. This is where you can define a flow by specifying all of the steps that need to take place, what all the inputs and the outputs are of those steps, which order the steps need to be run in, and then get back a flow ID that you can use to run the flow and launch a run of a particular flow that you or somebody else has defined in the system, and get the results of the run as it completes, and check the status of it while it runs. And then Globus Compute is the API that provides function as a service. Very often, Globus Compute is used as a step in one of the flows. So if you are defining a flow and part of it, one of the steps needs to be, okay, I need to run this piece of code on the server where I move the data to I don't know, maybe extract metadata or something like that. You can do that with the Globus Compute API. The ones that have stars on them, Globus Transfer and Globus Compute, are the ones that operate on either the Globus Connect software, Globus Connect Server or Globus Connect Personal, and all of the systems that have been connected with Globus Connect, or in the case of Globus Compute, that Globus Compute agent. So you would install the agent somewhere and then interact with it through the Compute API. So let's take an example of how this would all come together in one application, and then we'll dive into the details of each API. The example that I'm going to use is a data repository. This is a place where researchers can submit data sets, describe those data sets with metadata that allows them to be searched for and discovered. Things like, who provided the data, when was it submitted to the system, what's it about, what's the description, and maybe data types, things like that, or maybe it's experiment IDs. Anyway, you provide the metadata, and the data portal allows researchers to discover data sets on it. So in this case, we can build a data repository as a lightweight web application. And what I mean by that is that it's really just a Django-based web application. You can host it anywhere. You can host it in a container. You can run it on an EC2 instance in Amazon, or you can run it on your laptop. It doesn't really matter, because everything that it does is going to be done through APIs. API calls to our hosted APIs in Amazon Web Services. So you're not actually doing any significant computation or data analysis on the web server. You're doing it all remotely through APIs. One of the APIs that's available to you is the login Globus Auth API. So in your web application, you basically can just provide a link to Globus Auth for login and follow the well, I'll tell you about Globus Auth in just a couple minutes. But basically, you can provide login in your application just by calling Globus Auth. And people can log in with accounts that they have at universities or research labs, national federations, research organizations, etc. You can use the search API for the discovery parts. So in other words, either browsing by clicking on facets over here, that are presented by the search API query interface, or by here are the results of a search. We provide the ability to do free text searching, and so you can. Hang on a second, my do not disturb turned off because it was an hour. I'm going to turn it back on again. Okay. You can do quick free text searches. All of this is done using the search API. And so what the web application is doing is just providing the user interface in front of that API. You can call the Globus Flows API from your web application to make it so that when somebody clicks this button, a flow is run. And the portal can then display the status of the flow and tell you when it's done. And perhaps it will result in new data sets being in the portal, and you can go and find the new data sets that were created. Or maybe it did something to existing data sets, reprocessing them or something like that. But you can do it all with just an API call. The groups API you can use for access control. So for example, every entry in the search index can have a visibility constraint. You could make it so that in order to see certain entries, you have to be part of a particular group. Maybe it's the curator group, or maybe it's the people who are working on a particular project group. Doesn't really matter. What matters is that when the person logs in using Globus, we check their group permissions, their group memberships, and that then affects what results come back from search for them. And so you can use the groups API to add or remove people from groups, or to set visibility constraints on the search index. When you're actually looking at a particular result or a particular data set in the portal, there are more things that Globus provides. We provide a transfer API so that you can put a button in the portal that allows you to transfer all the data related to that particular data set somewhere else, maybe to download it. We'll get there in a second, but to transfer it to another Globus connected system, you would use the transfer API, and presumably when they click this button, it takes them to Globus, and Globus asks them, where would you like to put it? Maybe it's on your campus system, maybe it's on your personal system, whatever. But again, Globus handles all the details of that transfer and makes sure that it happens reliably. Your application doesn't have to have any code to do that. We also, as I mentioned, the Globus Connect server provides HTTPS access. So you can put web links in your application for preview images that come directly off of that, research storage, wherever it may be. So it doesn't matter that this is on some mass storage system at your campus. You can put web links into your portal, and they get served directly from your campus storage. And you can also implement the upload and download buttons in your application that way. So you click this button and it downloads all the data to your laptop, wherever you may be running your web browser. Or you need to add a file to the data set, fine. There's another, might be another button for upload. And it would open up the file picker in your web browser, let you pick a file, and when you say go, it just uploads it to the storage wherever it may be. So summing it up, this is not the last time. This actually, you'll see this a number of times throughout the tutorial. We have documentation at docs.globus.org. We have all of the software development kit code and the CLI code, the command line interface code, is all open source and available in the github.com/Globus organization. And then in this tutorial, we're going to be using Jupyter notebooks, which are available in GitHub, but we also have links for you. I'm going to just momentarily go back to this slide right here. I hope that that's still visible to you. Let's see. Yeah. So at this URL, if you go there, there is a training materials document that basically gives you all the links that I just showed. And so you might want to bring this up now in your web browser and bookmark it, because this is going to be important throughout the rest of the tutorial and later on if you want to go back and look at any of this stuff on your own and on your own time. And now I will quickly flip back to talk about the first API. We're going to be going through each of these APIs, and the first one we're going to cover is auth and tell you about logins in your application. So what I mentioned before about Globus Auth, the great thing about Globus Auth is that you can use your institutional identities that you are, your accounts that you already have to log into your applications. You don't have to have people create new accounts. Globus Auth is an OAuth 2.0 and OpenID Connect 1.0 compliance service. So if you have code in your application already to use OIDC or OAuth, you don't have to change anything in order to use Globus Auth. You just change your configuration to point to Globus Auth instead of whatever auth service you were using, and magically it will work with Globus logins. Globus Auth uses identity linking. The reason we do that is because researchers tend to have identities from many different organizations, not just a single corporation that they work for, but different campuses that they have appointments at, national facilities that they have access to through national allocation systems, other campuses where their colleagues work, and research federations that they are members of. And so what Globus allows researchers to do is to link up all those identities. And when you log into an application with Globus, the application can be aware of all of those identities, not just a single one. Let's see. Yes. Because Globus is standards compliant and OpenID Connect really only lets you return one identity, the way Globus handles that is that a single identity is returned to your application, but then all the other identities the researcher has are available to you in an additional field called the identity_set or identity set. And we'll actually see that in an exercise in just a minute. Your application uses the auth service in order to get access tokens. Access tokens basically are the authentication credential that you use when you call it a RESTful API. You call a RESTful API and you have to provide an authorization header. And what you put in there is the access token. It's just an alphanumeric string. The application, when you call Globus Auth to do a login, it will return tokens, access tokens. There are two different kinds. Let's see. I guess it was right here that I should talk about that. There are two different kinds. There are client tokens that use your application's identity. In other words, this is your application using an API to do something. Maybe it's to query the search index and display results. And there are user tokens. Those are tokens that you get on behalf of the person who's logged into your application, that allows them to, say, access their personal files on a Globus Connect personal server or on a campus system. So it uses their identity and their permissions in order to do things. Let's see. Globus provides refresh tokens. So because access tokens have a limited short lifetime, maybe 12 or 24 hours. And if you want to be logged into an application longer than that, the application can use Globus's refresh tokens to get a new token when the old one expires without the person having to log in again. And then there's also a log out function to revoke all those tokens so they're no longer usable, even if somebody happens to find them on your server, and close any auth sessions that were opened. The auth service does a whole bunch of stuff behind the scenes that I'm not going to talk about, but one of them that is very important is we integrate with thousands of identity providers. Most of these are universities. So if you need to, if you have a researcher who works at University of Chicago, they can log into your application using University of Chicago's login service, and Globus provides that integration for you. You don't have to do anything in order to make that available. You just enable Globus logins, and magically your Chicago researchers can log in with University of Chicago. Penn State researchers can log in with Penn State. People can log in using their ORCID IDs, etc. They do that using Globus, and we handle that integration for you. In order to use Globus with any application, the first thing you have to do is register your application. And so you use the Globus web app that I mentioned earlier, app.globus.org. You log into the web app and go to the settings section, and there is a developers section there, and that allows you to register applications. You click on a link and it says, oh, tell me about your application. Give me a little bit of information and I'll give you a client ID and a client secret that you can use in the application in your configuration. And you can use that for getting client credentials. So the client ID and client secret in your application allow you to get client credentials. What does that look like? It basically is you call a standard API call from, I'm not even going to go into the details here. It's in the documentation, and that results in access tokens that your application can use to do things as itself. So this is not things that you do on behalf of your users. You don't have any of the users' permissions at this point. You only have whatever permissions have been given to your application. You can run flows, you can submit compute functions, you can query a search index or even update entries in a search index. Whatever's been granted as a permission to your application, you can do with these tokens. If you are doing any automation, you should probably be using client credentials and client IDs rather than user IDs. So in other words, don't set up an automation that uses your university account because first of all, when you do that, the authentication requires web browser. It's interactive. If you're doing something in an automated fashion, you don't want it to be interactive, where you have to actually open up a web browser, go through your campus's login or whatever. You want it to be something that you can do with just that client ID and secret, and it's invisible behind the scenes. Also, you don't want your automation to be tied to you. If you take a different job somewhere, the people who take over for you probably want to continue using whatever automation it was. It's better for it to be tied to a client ID and secret that you can share with your successor so that they can continue using it and it doesn't require continued use of your account. All right, so what do you do when it's time to do things on behalf of people who are logged into your application? First of all, you have them log in using Globus, using the Globus auth API. You use an authorization code flow to obtain user tokens that are tied to the user's identity. So whoever is logged in, everything that you do with those tokens use their permissions. And so it's the permissions of the person who's using your application. Whatever groups they might belong to, whatever accounts they've been given on various systems and they've linked in Globus are then available for the application to use on their behalf. One of the things that is important about Globus and about the fact that we are using the OAuth system is that Globus will automatically ask people who are logging into your system to give the application permission to do things on their behalf. This is called consent. And so, when a person logs into your application, if you've said, I'm going to transfer files for them, I'm going to query a search index for them, I'm going to run a flow for them, Globus will ask the person when they log in, will you allow this application to do these things on your behalf? They'll click yes, and you will get the access tokens that allow your application to do that. If they say no, then you won't get those access tokens, and you'll have to tell the person who's logging in, I'm sorry, I can't do what I need to do for you because you didn't give me permission, and maybe give them another chance. Let's see, I'm going to skip this, and we're going to go directly to the first demonstration, the first exercise, since we're running slightly behind schedule. Again, if you want to follow along, I'm going to do this on the screen, but I invite you to go to jupiter.demo.globus.org. This is a tutorial materials file that you should have in your browser now. But if you want to go there directly, just go to jupiter.demo.globus.org, and you find using our sign-in sheet, you should be able to log in, as I'm going to do right now. I'm going to stop sharing, hang on, and reshare. Whoops, reshare my browser now. There we go. Share. So you should be able to see my browser now. And when you go to jupiter.demo.globus.org, you should get this very simple sign-in screen where it asks you to sign in with Globus. Now, I've already done this, so hopefully it'll just log me in. For you, it will probably ask you how you want to log into Globus. Pick an organization that you belong to and have an account at. And if you don't, pick either Orchid or Google and sign in with that. And when you are signed in, it will give you your very own Jupyter Lab instance. We're using Jupyter Lab here. We have an integration with Globus already. And if you make this a little bit bigger, you can see that over here we have a folder called Globus Jupyter Notebooks. And we have a whole bunch of different notebooks in here, which are examples. I'm going to go to, oh my goodness. Yeah, Platform Introduction with Native App. That's the example I want you to open up. And this is just going to show you how Globus Auth works from a code perspective. So the first thing you have to do in your code, obviously, is do some imports. In this case, we're going to import JSON. Because we're doing this in a Globus Jupyter Hub environment, we've already imported the Globus SDK. So you'll already have availability of everything that's in the Globus SDK. The first thing we're going to do here are set up, import the JSON library and also set up some startup variables. And then remember I mentioned to you that when you are using any of the Globus APIs, you need to have a client ID. And in this particular case, we don't need a secret because we're going to be using a feature that doesn't actually require the code to be authenticated. We only need to have a client ID. So we're going to set the client ID. We've already set this up for you, and it's going to spit out a login URL. So that's exactly how it works in your application. You call this particular call, Globus SDK, native app auth client, and give it the client ID as a parameter, and it gives you back a URL. And that's what you have to present in your application to the researcher. They will click that, and it will take them to Globus. And just like I told you earlier, it'll ask their permission for the notebook to do things on their behalf. It'll, in your case, it'll give whatever the name of your application is. I'm going to allow that. Oh, I have to type in something here. Tutorial demo, allow, and it spits out a code. This is because this is the downside of using the unauthenticated version of the login. If we were using a client ID in secret, this step would not be necessary. But in this case, we have to come back and paste in the code that we got back from Globus so that our application can now get the tokens that Globus is returning to us. That code basically allows the application to retrieve the tokens that go along with that login. Now, let me just double check here. Yeah. Okay, so at this point, I wanted to show you what does it look like. So let me really quickly, I had a note for myself somewhere. Oh, darn. I lost my note. Okay, so I think I'm just going to skip, but basically, you need to have a little bit of faith that this token response here now has in it all of the information about the person who logged in. It's Lee Liming from the University of Chicago. It knows that because that's how I logged in with Globus, and my email address and all kinds of stuff like that. So now if I wanted to in my application, I could create a user profile. I could tie it to the identity that Globus returned, lliming@uchicago.edu, and we'd be good to go. So that is all I wanted to show you really about Globus. You can see that it's very little code. You need this client ID here, which you get by going to app.globus.org and registering an application. It gives you this string right here. And then you call this native app auth client call with that as a parameter, and display this login URL for the researcher to use. Actually, in most cases in an application, you would just redirect the user's browser to this. You wouldn't even display this link. You would just automatically take them there. And then it would come back to your application with another redirect. And that's when you would get the code, and you would call these calls to get all of the tokens that you need in order to do things for the user. I'm going to switch back real quick and talk about a couple other quick APIs and then turn it over to Steve. Let's see. Oh, I did not reshare. Reshare. There we go. All right. I'm not going to go into a lot of detail about the Groups API in this tutorial because we just don't have enough time. And so I want you to know that there is another API called Groups. Here's where the documentation about it is, where you can learn how to create groups, how to configure them. Most people create and configure groups in the web app and then use the API to do things like look up memberships to see if somebody is a member of a particular group or not, and add or remove members from groups. But you can use API calls for all of those things, for creating the group, setting its policies, etc. It's all in the documentation. The nice thing about Globus groups, though, is that you can then, if you want to have a permission in your application, like, you know, this particular area of my application is restricted to people in a particular experiment or in a particular project, you can create a group. You can manage the group's members using Globus, and then you can, in your application, check to see if the person who's logged in is a member of that group or not. And if they're not, then you can disable that part of your application. And if they are, then in they go. So it's a really handy way to do permissions without having to do all of that in your own application's code. All right, let's see. Oh, I just said all that. Okay. All right. The next API I wanted to cover is Globus Search. So Globus Search is another API that Globus provides. It allows you to create search indices, to configure them, to set permissions on them, to add things to the search index, and we call them entries that basically have descriptive information about something, whatever it is that your search index is being used to search for. And then to query the search index to find out, show me all the entries that match a particular criteria. It's schema agnostic. You can use whatever schema you want. Globus provides the storage for your search index. So all the entries that you provide, you could provide millions of entries and use up, I don't know, gigabytes of storage, hundreds of gigabytes of storage potentially, and Globus hosts all that for you. So all you have to do is call an API call to create a search index and then start shoving stuff into it. And assuming that you've provided good name value pairs in your schema, Globus will automatically index everything, and you can call the query API to find all the entries that match that. This is what posting or putting new entries into Globus looks like. This is not the code to create the index. We'll get to that in the Jupyter notebook in a minute. This is after you've created the search index. You can add entries to that search index. So in this case, there's a subject that is, this is the thing that you are, one of the many things that you can search for in the index. You can say who it's visible to, and you can put whatever metadata you want in about it. So in this case, it's just, I guess, the metadata schema I filed. It's basically just the information about the file. And that can be whatever you want. It can be size, it can be a person, it can be the size of the person who this data is about, doesn't matter. You can, in that visible to, instead of making it public, you can say, I want this thing to only be visible to a particular person. And this is the Globus auth ID for that particular person. These are all UUIDs in Globus, but it's actually something, corresponds to lliming@uchicago.edu or some other user identity. Or more usefully, probably, this could be a group. So instead of Globus auth identity, this would be Globus auth group, and then there'd be the ID of a particular group. And so anybody who's in that group would be able to see this entry in the index in the search results. And anybody who's not in the group, it would be invisible to, and it wouldn't come back in their results. This is what the query interface looks like. This is a simple query where all you're providing is a search string. So in this case, it's I want to look for entries where the type is equal to HDF5. This %3a is just an equal sign. And so I think it's some symbol anyway. It's a symbol that separates the field name from the value. And what you will get back is a list of entries that match that particular, that basically have, type is HDF5 in their metadata. So assuming that you put that in your metadata, search result or the entries will come back in the search results. This is a simple query though. So this is just, you provide a query string and it gives you everything that matches it. A more complex query is, I'm going to provide for you a set of filters. It could be, fields with particular values. It could be ranges. It could be geospatial coordinates, as long as you had a field somewhere in the search entries that have geospatial coordinates in them. And then you also specify not only, give me all the filters, and show me all the entries that match these filters, but also tally up for me the values of these particular fields from all the entries that matched. And tell me how many entries matched each one of these particular things. So, all of the ones that had a particular publication date or a particular, experiment ID or a particular whatever. And what the application is then going to do is it's going to use it to display a faceted search index or interface that allows the person using the application to just point and click at, okay, I want only entries that match this particular publication date. And then you can do another query with that one as one of the filters and get back a new set. And so it allows the person to browse the search results. So we use complex queries for that. So complex queries allow you to specify filters and facets. All right, let's go back to our Jupyter notebook again, and I'll show you how this works. So I'm going to stop sharing. I'm going to reshare. There's my, sorry, I'm losing track of my Zoom. Okay. All right, you should be seeing my web browser again. I'm going to go to a different notebook. You can follow along at jupyter.demo.globus.org. Where is it? Metadata search and discovery. There it is. Okay, so I'm going to open up a different notebook. This notebook uses a different way of getting tokens. Because I logged into this Jupyter Hub using Globus, there are actually tokens that are available for me in the Jupyter Lab environment, and that's what I'm going to use for this particular notebook. So the first thing we're going to do in this search example is import the Globus SDK, JSON, and MINID, which is a DOI, or Digital Object Identifier service, that allows you to create DOIs for things that are persistent and that you can rely on not changing in the future. I'm going to have a client ID just like before, but wait a minute, this is the ID. Yeah, okay. And then I'm also going to specify some canned identifiers for, in this case, a tutorial. This is an endpoint storage system that's available via Globus. And the host name of its HTTPS interface. Here's a group that we're using this is actually a group called tutorial users. And it says up here, there's a link. If you're following along, make sure you click on this link. And what it'll do is it'll take you to Globus, and it will allow you to join. You can automatically join this particular group called tutorial users, because the search results that we're going to be seeing here are only visible to people in the tutorial users group. The next thing we're going to do is we are going to get the tokens that are already available in Jupyter Lab for me, because I logged in using Globus. There's one for transfer, one for search, which we're going to use for the search API, and there's one for the I don't even know what that is. It's an access token for probably one of the tutorial storage systems. And let's see, we're going to print those tokens. You can see this is a good example of what an access token looks like. This is encoded in the JSON web token format. So it's just an alphanumeric string. You would use this as an authentication header on an API call. And that's what we're going to be doing later on. And then using the software development kit, we're going to create objects in Python for interfacing with the transfer service, the search service, and the DOI service that I mentioned earlier. The next thing we're going to do is we're going to create a demo data set. So let's see, what is this going to do? Oh, it's transferring something. It's creating a directory. Right. We're going to create a brand new directory using a UUID that we generate on our tutorial endpoint. So this is actually on a storage system that Globus operates for you, for people who are participating in tutorials. And we created a directory, and it gave us a link. If I click on that link in my browser, it'll take me to the Globus web app, and it will show me that it created a directory for me, and the directory is empty. So basically, this is what an empty directory looks like in the web app. And let's go back here and put something in that directory. The next step is to perform a transfer. We're going to transfer a file that already exists on the tutorial endpoint to a directory on in our new folder. I'm sorry, we're going to transfer the file to the new folder that we just created. This is what this is a preview. Steve will talk to you in more detail about what transfer looks like. And we are actually, I'm going to skip over this part. This is basically just waiting for that transfer to complete. I'm going to assume that it will complete very quickly. And we're going to set an access control rule on the directory. It actually can do that even before the transfer completes, because it doesn't matter if there's anything in the directory or not. We're going to create a new metadata entry. So I can put whatever I want in here. I'm going to put my own name, and I'm going to put Tim's name. I'm going to change the date to today, 10/4, I believe. Is that right? Well, whatever. And I'm going to change some keywords to whatever. I'm going to create that data structure. Now I'm going to, this is a little bit of extra detail, create a DOI, that is a persistent identifier for that particular thing. It gives me a handle ID. And now I'm going to, let's see, look up that handle, make sure that it's really there. Oh, that's interesting. That didn't happen to me before. I don't know why it's doing that, but I will do it anyway, real quick. At this point, it's probably a good idea to remind you all that that emergency alert test is going to happen sometime if it hasn't happened for you already. So don't be surprised if your phone goes crazy. I have no idea. Oh, okay. I think it's down here that I wanted to do that. Yeah, down here is where I wanted to display the identifier. So this is just to prove to you that we did create a digital object identifier in the Minid server. It's a handle, and this ID will always return all this information. That's important because now we're going to stick it into our index, our search index. So it's important that you have a persistent identifier when you do that. I already had a tutorial index, so it skipped creating one for me. That's fine. Now I'm going to actually publish the stuff into it. And now we're going to view the result. This is a simple web portal that just displays results from Globus search. You can see all the metadata that I put in there. Here's Marvel, here's Thor, here's me and Tim and somebody else. So all the data is going into the search index and is now being pulled out in the portal. And if we wanted to search for something like Timothy, for example, we could do that, and it would return just the one entry in the search index that matched that. And it found Timothy here in Timothy's name. And this is what a search result looks like in the Globus Search API. I think I'm going to stop there and switch over to Steve because we are running short on time. Steve, you might only be able to get through a couple of the others. I'm not sure. Sorry about that.
No problem. Can you, oh, good, there we go. I'm going to move at a lightning pace. I might even forego slides here and go right into the Jupyter Hub notebook. So I'm thinking since this is a developer centric thing, you probably are going to want to see code over slides. but I'm happy to share my slide deck with anybody that might want to take a look. So what I'm going to try to fill in here in the next 15, 20 minutes is Lee showed Globus auth in that Jupyter Hub. And I'm going to continue that notebook and just show some basic transfer. From there, I'm going to work into our automation service called Globus Flows. If you're familiar at all with AWS step functions, it's built basically off of that. And the machine state code looks very similar to what you would use with that service in AWS. And then finally, I'm going to go quickly into our compute, which I guess you could probably compare to something like Lambda. But what is running the function is wherever you have your Globus compute endpoint installed. That can be really any remote machine that you can connect to, install that, and basically get a UUID from that Globus compute endpoint that you can use to run functions on that system. So I'm going to go ahead and just share my screen here. There we go. All right, hopefully everybody can see that. So this is where this is Lee. This is where he did his Globus auth. If I quickly just look at the Globus app, the web interface, we're going to be doing something very similar to just transferring from one endpoint to another endpoint. So we're doing this programmatically rather than through the actual web app. So if we go back to this particular tab, I'm going to run the authentication pieces of this, which you are already familiar with. Okay. Okay, there we go. Okay. That was a little bit jarring and frightening there, but I think I turned it off. Anyway, I'm going back to my laptop, going to allow, I'm going to grab this code just like Lee did before. Hopefully people weren't as spooked by that as I was. So now with this code, I'm going to exchange this code for a token response. I'm going to use this token response and grab the actual access token for the transfer API by the resource server. So I have a transfer access token, which I'll then use in an access token authorizer, basically just creating bearer auth headers. And then I'm going to create a transfer client that I can use basically to do anything within the transfer API. So let me run that. This is just a little helper method. If you run this, you can see some basic things that are within this get endpoint function. I'm going to use this get endpoint and I'm going to display some information about it. So we have a 200 status code, which is nice. The content type is application JSON. And then the data within it is just some basic data about the endpoint itself, the URI, what scheme we're using, if there's any subject, host name, and so on and so forth. You can read through this if you like. There's a lot of information about the endpoint owner ID, the owner string, subscription ID, if there's a subscription associated with the endpoint. We can do an endpoint search once we have a TC client. So here I'm doing a filter scope of my endpoints, and the endpoints that I own is my actual personal endpoint, which is Globus Connect Personal. And we can do a full text search to look for endpoints. So again, once we have that transfer client, we're going to do a search for a Globus tutorial endpoint, which we saw before. We got an endpoint ID, and there are more matches because there are more endpoints that match that tutorial, that full text search. We can handle errors in a try except. Running this, we'll just say no endpoint found. So it just returns some helpful information about whatever error is that you're catching as an exception. Again, I'm going to go quickly through this so you can read through the 5 basic classes of errors as you work through the notebook yourself. This is doing similar to what was done above, but this is matching all endpoints. This is actually just spitting all the endpoints out that match the tutorial text search. So you can see there's quite a few in here. Recently used, if we do the same search, it'll narrow it down for me for ones that I've recently used. And again, getting some more endpoint details here, owner ID, network use, and parallelism. Okay, so endpoints on occasion will need to be activated before they can be used. That means associating a credential with the endpoint. So we can do that through the SDK as well, pretty easily just by running endpoint auto activate and then giving that the endpoint ID. So we should get a response, hopefully, that the activation was successful. We'll get a directory listing. So there's not too much in here, just some example files for the tutorial itself. We'll make a directory within that with that particular endpoint. So the directory is created successfully. If I go over to my file manager, you'll see the tutorial directory here with nothing in it. We can rename it. Again, hopefully, if I go over here, up a folder and refresh, there's a renamed directory. So here's where we're going to actually submit a transfer. We have a source path. Actually, excuse me, before that, we have a source endpoint. So we're going to go from tutorial endpoint 1 to tutorial endpoint 2. The source path is that Go data directory we saw with the text files. The destination path is the sort of the root level directory that I would have access to. We're going to give it a label just so we can, I can even just do something like tutorial transfer. We're going to create a transfer data object, and we're just going to give that the transfer client, the source endpoint, the destination endpoint, and the label. From there, we're going to add items to that based on the source path and destination, and we're going to say it's recursive because we're actually transferring a directory right now. So let's run this, and hopefully we're good. Yep. So now we have a task ID because we submitted it. So let's go back to our activity. Here's the tutorial transfer with that label. It's completed successfully. Events will see started, progress, and succeeded. Again, if we go into this tutorial endpoint and we refresh, sorry, that's in tutorial endpoint 2. Where did that go to? Here. There it is. So there's 3 text files that we transferred from endpoint 1 to endpoint 2. We can get some information on the task. It's already completed. So we see that succeeded, bytes transferred, files transferred, and the transfer rate. And the destination endpoint. Here's that list of files. And I'm probably going to skip the tasks for the rest of this because I only have a few minutes left. So in any case, with the transfer client, if we submit long-running tasks, we can get the status of that, as needed. You can maybe see it as like doing it every couple of seconds or every couple of minutes, depending on how long your transfer is going to be. We can delete files. So if we want to delete files and clean everything up, we can do that as well. And then we'll wait for that task to complete. Again, I'm not going to run these things because I'm going to move on to flows next. So again, that was rather quick. The basic submission for to actually create a task and transfer isn't terribly difficult. That's all done right here. You just need an endpoint ID as a source, an endpoint ID as a destination, a path for the source and path of destination, label if you want, and then just use that transfer client to add data to a transfer data item. Okay, that's the transfer API and SDK in a nutshell. Automation, flows. So this is a quick example. If I go over here to the web app, we can see some example flows, and we'll see these definitions in code. But we define these with state files, machine state files. Again, this should look pretty similar to what an AWS step function is. Really, the only difference is we're defining, and you'll see as we do this, let me go through the beginning of this as well. So really what we're going to do here is we're going to define a flow that initiates a Globus transfer to move data to a guest collection, and then we're going to add an access rule to allow a group access to that data. Pretty simple. These flows can get fairly complicated, but let me run this. Authentication here is through those tokens that Lee had spoken about that were quote unquote pickled in our environment once we logged in. So we're going to get a flows client almost identical to how we got that transfer client before. You're going to see this kind of paradigm in our SDK where any kind of client you want to work for, you're going to have to request the scope and get the access token for that, and then pass that access token to an authorizer, which is then passed to a client. So now we have a flows client. This is just some identity. So username and ID notifications are going to be sent to my email address. So here's the flow definition. We're going to create a flow that transfers files to guest collection and sets access permissions. We're going to start at transfer files, which is defined within the state here. This is a type action, and here's the canned action URL that Globus has created for this type of for this leg of the flow. We have a few different types of action URLs. We have search, one's for permissions, one's for auth, one's for transfer. Those are well documented. You can even create your own action URLs if you want. If something needs to be a little more custom, you can create your own and you can add that in here. So this is just taking an input source destination, kind of like we did in the previous transfer. This is taking this in a definition file. And then we're going to set permissions on that destination ID path. We're going to set it to read only and input a group or a principal identifier. So let's define that flow. And we're going to define an input schema. So this is what is needed to get inputted into the actual flow to make it run correctly. So you see above here, we're sort of defining what that input schema is going to look like in the flow definition. We have required objects, I should say, yeah, you have required objects, and then properties defined from above. So we have our source or destination. How should that look and how should that be defined? Whether or not it should be recursive, if it's a directory, the principal type and the principal identifier of the group. So first we're going to deploy the flow. We're going to give it a random flow title so that we can see it. The flow definition, title, and input schema are going to go into that deployment. And then we're going to use that to actually execute. Okay. Input schema. Okay, there we go. So we successfully deployed this flow. The flow scope is going to need this next in order to actually authorize and execute the flow. Each flow has its own scope. We can view this flow in the web app. Hopefully it'll open it in a new tab. Yes, good. So here's the flow definition. We can see the definition here, exactly how we created it. And we can see the input schema. So let's authorize this flow using this scope. Get a new authorization code because we didn't. We need to reauthorize because we didn't consent to this scope yet. So now we have this scope with the access token that we need. So now we have to actually give it an input. We already defined this source collection and destination. So we'll give that we'll create that input. And now we're going to run the flow with all of the stuff that we've defined above. So we can monitor the flow here. Let's open that. Let's check the event log. So you can see the flow has started, the transfer file action has started, and the flow has succeeded in about 2 seconds, maybe, second and a half. So we can see that here. We can also see the output in the, so if it's hopefully successful, we can see this flow action data, the run ID, flow title, details, and so on and so forth. And it shows each leg of the flow. So did the transfer files succeed? It did. Did the set permission succeed? It did. And if anything failed, it would say that in that leg of the flow, and it would give a reason why that it failed, hopefully. And then we can view files that we've moved. So this might be, not sure why it's not showing, but hopefully you can trust that the files are there because it did run successfully. And then we can remove the access rule if needed on that flow. And that's, again, very quickly through flows. Lee, I know we're at time. What do you think? Should I move and introduce compute, or should we kind of call it there?
Well, we're trying to keep on schedule because folks have other meetings and things like that.
Understood.
Sure they can go to the Jupyter notebooks and follow along on their own time. They look like they are a great resource, and I'm sure there are other ways that they can get some additional information on there. But I think it was a great introduction to the capabilities of Globus and some things that it can do and how to go about doing it, and some resources to learn more. So thank you, folks, both Steve and Lee. How about we all give them a virtual round of applause? Yay!
Thank you.
And
Thanks,
the alarm announcement wasn't too disruptful, so we managed to get through that as well.
Yeah.
I'd like to remind everyone that this was recorded and slides will be available at some point. I'll just wait for follow-up details. Again, if you're not a member of the US-RSE and would like to become one, you can join at the US-RSE webpage. I've dropped the links in the chat there, along with the pointers to the materials, the Jupyter Notebook. And there's also a tutorial feedback form for the tutorial as well. So if you please go ahead and fill that out to give our folks some additional feedback. And Lee dropped in support at globus.org as well to get additional information as well. So thanks everybody for attending, and we will see you next time.
Bye-bye. Thanks.
Thank you.
Bye all.